So, first let's try to understand how a space-time diagram works. If we consider a 2D space-time, a two-dimensional axis having an x-axis and y-axis. X-axis, which is space, and t is y-axis. Where in this time axis, if we place a stationary object, particle A, this particle A is a stationary object. This stationary object will always move in forward direction, in time direction. It won't move in x direction, which is space direction. So it doesn't have any movement in x direction. So if we are in motion, if we consider this A particle as in motion, this is the space-time representation of particle A which is in motion. It will bend towards space axis. This bending or tilting towards space axis is completely dependent upon the velocity of the object or particle. So if we consider light, so if we are talking about light will always bend towards 45 degrees angle, which will make a 45 degrees angle towards the time axis and space axis. There is a reason, because speed of light is constant, which is 3 into 10 power 8. Into 10 power 8 meter per second. Speed of light is 3 into 10 power 8. So if we consider 1 unit towards x-axis and 1 unit towards x-axis and 1 unit towards space axis, then we will get a straight line, diagonal line. We will get a diagonal line which makes a 45 degree angle. So light will always travel at 45 degree angle. The remaining particles, so we know that 45 degree is the constant for speed of light. So any particle which is traveling lesser than 45, lesser than the speed of light, will always make shorter angles, like this A particle. Like this A particle will make some 10 degrees of angle or something. The particles which are lesser than the speed of light the particles which will move lesser than the speed of light will always make lesser angles in the space-time diagram. So the speed of light will travel in all directions. So if we consider negative axis to x-axis, negative x-axis, and positive y-axis, which is time axis, and y-axis, just time, negative time. So this is 45 degrees. This is 45. This is what we call a light cone. This cone representation is a light cone. This is what we call a forward light cone. This is a forward light cone. So every particle which is moving will always move in this direction, time direction, with certain angle less than 45 degrees. They will we know that anything having mass cannot able to travel faster than the speed of light, cannot able to accelerate near the speed of light. So this 45 degrees of light is from our perspective, not from light's perspective. So like in the light's perspective, it will totally space like, because when it is traveling, it x-axis will be 3 into 10 power 8. Time axis will be 0, t is equal to 0. So it will travel like this. its time axis will be 0. It's from light's perspective, light's frame of reference. This is from observer's frame of reference. So according to Albert Einstein, special relativity postulates from early 1900, Einstein proved that while traveling or reaching closer or moving closer to the greater speeds and ultimately reaching speed of light, we have to give infinite amount of energy in order to push that object to the velocities. So what if there is another way of looking into physics, like outside of boundary of this postulates of Einstein's relativity? Then in the year of 1967, enter the physicist Gerald Feinberg, a Columbian University physicist, first proposed an idea: what if there is another side of this physics boundary? In 1967, Gerald Feinberg and Columbian University physicist. So 1967, Gerald Feinberg, while he was studying on Einstein's relativity, he got this thought that what if we keep we know that the general equation for energy relation of Einstein, which is E equal to mc square. So this is for non-relativistic speeds, relativistic speeds. So for non-relativistic speeds, we have to write this will apply for particles which is moving slower than the speed of light, which is having mass. So if we consider particles which is having, like, which are near the speed of light, then we have to consider the momentum too. So then this equation will be written as E square is equal to m square c power 4 plus p square c square, where p square is the momentum of the particle, where p square is the momentum of the particle. So we have to do is, so if we keep the mass as imaginary, m is equal to I, which is I is the square root of -1. So if we keep the mass negative values, so it may be -2. So he thought that, like, we know nothing can with mass can able to move faster than the speed of light. You know that any object having mass cannot able to accelerate or move closer to the speed of light. So what if the mass of an object is imaginary? Then mass can be either negative or positive to zero. In 1967, Gerald Feinberg published his paper on possibility of faster than light particles. In his research paper, he first introduced the term tachyon. Which is coined from Greek. In Greek, it will be like pronounced as tachys, which means swift. So he named these particles as tachyons, which can only travel faster than the speed of light. So in a space-time diagram, the tachyon will always travel outside the light cone. Sometimes they will enter the light cone. So that can be represented as, so in this diagram we are represent, so in this picture you can see the tachyon appearance in 2D space-time fabric. So I'll show you how it appears. So we know this is a light cone, 45-degree angle of light. So the tachyon will all Gerlfenberg describe that tachyon particles tachyons which will move faster than the speed of light can only able to travel outside of the light cone. So when a tachyon is present outside of the light cone, so it will travel like this or something like this. We can only able to uh, we can only able to locate or prove, or we can only able to discover particles which we can able to see is inside the light cone. If we are talking about the outside the light cone, we cannot able to notice, because in order to do this we need to send signals faster than the speed of light, which we cannot able to do. So for tachyons we have to give infinite amount of energy to reduce the speeds to zero. So but in physics we know that in order to increase the object speed velocity, we need to give infinite amount of energy to reach the velocity of light, to reach the speed of light. But for in the tachyons case we need to do the opposite. So when a tachyon travel from outside of the light cone, which is completely space like, so inside to when it travel from outside to inside, it will appears like this. This is the detectable space or visible space, whatever we can. So it will start from a like point, and slowly it will come to 2D, it will come to 3D, and slowly it will start, and it will slowly when it is exiting the light cone, it will do the opposite. It will slowly disintegrates, like it will become smaller and smaller, and it will completely vanishes. It will start from disappear. It will start from appearing from nothing, and it will, when it is leaving the light cone, it looks like it is disappearing into thin air. That is what tachyon will look like in our perspective in 3D space time. So while exiting, it look like becoming small and vanishing into thin space. If you want to study or discover them, to capture them, it is only possible to do it can only possible to do when they are in the in this present space, or inside the light cone, inside this light cone inside this is the light cone boundaries, and this is the space like, which we don't know how it will look like, or how we need to describe them. And these are the places where tachyons, particles like tachyons, can able to exist. Particles having imaginary mass. mm, yeah, if you want to study or discover them or to capture them, it is only possible to do in the inside of the light cone, when they are inside of the light cone. While studying and understanding this topic, we need to face too many by paradoxes which will create by tachyons perspective. Like uh, when a tachyon is passing through between two different observers, like stationary observer and a moving observer, we need to face many paradoxes. So like uh, while studying and understanding this uh, tachyon topic tachyons topic, I have faced many questions and doubts, like what are these tachyons properties, what is the nature of the field space that is allowing these particles to move at this kind of speeds, and is it possible that a tachyon is a higher dimensional particle, maybe, like, does it have connection with time dimension or something, or how does objects behave outside the light cone, uh, which is lesser time like and higher space like interactions, and how can we able to capture them if they can't even slow down than the speed of light. How you can you even able to visualize an object or a particle having an imaginary mass or a negative mass? How can you able to represent them? How can you able to visualize them? Does coming in and exiting light cone looks like appearing and disappearing of particles or objects out of thin air? Is that how they look like? Is this how we supposed to perceive for stationary observer or a moving observer? How can you truly experience a tachyon passing by for a stationary frame or a moving frame? Obviously, it feels like breaking causality, and we get the readings, and it would feel like we will get the readings before we even started our calculations. Like thinking of thinking of tachyons, we also cannot ignore their paradoxical behaviors. Uh, how can we understand and solve and explain these kind of paradoxes? What does tachyon interacts with? And there are many more questions like this. The people who are watching this, I'm asking you to think about these questions and give me your logical and possible theories and thoughts on these tachyons. This whole thing what I said is from my own knowledge of understanding tachyons, which I read about, and I still have to read and study many more research papers that I have on tachyons. But once I have good grip on my basics and fundamentals on my math and calculus, then I can able to study those papers and understand them. And then I will go to study higher studies, and I will study hard, and I will prove and discover the method to capture tachyons, and I will propose a new way to understand the paradoxes of tachyons.